In the last few videos, we were learning about electrical charges. We know that opposite charges will attract so similar charges. Let's use the same color because they have the same type of charge. Will repel. Now we move on to magnets. We know that charges are positive or negative. With magnets, we use different terminology or different words, different vocabulary. With magnets, a single magnet always has two ends, north and south. Every magnet has two ends. In fact, if we cut this magnet into two pieces, so now we have two pieces, each piece will have a north and each piece will have a south. So there are always two ends, north and south. Just like electrical charges, if we have two north next to each other, then they will repel. But if the north is next to a south, then they will attract. So we said magnets always have a north and a south. Why? Well, we can understand this when we understand compasses. A compass is a device that looks like this. It has a needle with two ends. One that points north and one that points south. So this is called the needle of the magnet, the compass. So for example, if we put a magnet like this, the north here will attract the south end of this needle. So the needle will move like that. So one way to make the needle of the compass move is to use a magnet. Why is the compass useful? Well, the Earth that we live in is one big magnet. It has a magnetic field that looks like this. In fact, the south pole of the Earth, its magnetic field, is on the north, and the north pole is in the south. But that means that if we're here and we have a little magnet like this, let me draw it better. We have a little magnet like this. Or for a better example, let's say we have a compass. So here's a little compass. Remember that the compass has a needle. Well, the north end of the needle will attract the south end of Earth's pole. These attract. And the south end will attract the north end of the Earth's magnetic pole. In other words, the compass can tell direction, can tell us which way is north, south, east, west. So here's a compass. One way to make it move, one way to make the needle, we know that one way to make the needle of the compass move is by using a magnet. Bring in a magnet, and the needle of the compass will move. It will be attracted. Like that. Well, there's a second way. Instead of using a magnet, we can use electricity with an electrical current. How does that work? If we put a wire here, so here's a wire hook it up to a battery, maybe at a switch like this. Right now there's no electricity, but when we close the switch, now there's electricity, there's electrical current going through this. When there's electricity, the compass needle is also going to move like this, actually. If the wire goes like this, the compass needle will go like this. So electricity also makes the needle of the compass move. So the big idea here is that electricity generates, that means to make, a magnetic field. And with a magnetic field, that means that the needle of the compass can move. Remember, this is the needle of the compass. That's it. We will continue tomorrow.